Hello everyone, myself Professor Chavan. We have started the third chapter from our 11th Science CBSE board for the subject physics. In previous lecture, we have learned about the method of a calculus, that is the differentiation. Okay. In the method of a calculus, in a differentiation, we have to go for the rate of change. Okay. So when we have one curve and we have to find out the area under that curve, and if the curve is like one irregular profile, then we can use the method of the calculus. Okay. So the first method we have seen, in which whenever we have to go for finding the area under the curve, then we can divide that area and accordingly we can find out the area under that curve. Okay. Also we have seen that the slope of that tangent, which is tangent to the curve, gives us the differentiation. Okay, it gives us the rate of change. Okay, we have seen the xt curve, in which if this is the one slope, then the tangent to this slope will give us the rate of change. Okay, it will give us the derivative value, and in that we are going to combine the two methods. That is, the one is the division and the second one is the difference. Okay, so we are combining the division and the difference totally, and we are getting the new concept there, the new method, that is the differentiation. Okay, here we get the slope is equal to, suppose, 1 dy by dt, or we can say it as the dx by dt. Okay, here always we have considered that the value which is continuously changing, that value we have to consider along the x-axis. Okay, so accordingly we have to take the area under that quantity only. Okay, on that axis we have to take the projections from that graph, and we are getting that value of the area. Okay, here we are taking slope is equal to dy by dt or dx by dt. This gives us the value of the dx by dt. This gives us the value of the differentiation. Okay, by that also we can get the area of that particular curve. Okay, then we have seen the combination of the difference and the division. Here it is nothing but the difference of the physical quantity, and here is the difference of the basic quantity. Okay, accordingly we are taking these two differences and we are getting the value of the rate of change. Okay, it gives us nothing but the rate of change. Okay, and rate of change is nothing but our value of the differentiation. Okay, we are getting the value of that differentiation. Now the second part is the integration. Okay, in the integration, so suppose we are having one curve. Okay, we have the one curve and we have to find out the area under that curve. Then what we have to do is we have to divide that curve into number of small parts. Okay, and we have to take the area of that particular parts respectively. Suppose this is the one graph we are getting, and in this graph, if this is the one A curve we get, then in this case, suppose this is the x and this is the y. Okay, this is x and this is y. In these both cases, if we have to find out the area under this curve, then in that case we have to divide this area into number of small parts. Suppose we divide this into some vertical small parts. Okay, the small vertical parts we divide it into. Then what we have to do is we have to apply our standard formulas here. Okay, if in such a small parts, if we divide this area, then to consider these small parts as a one rectangular shape, if we join these lines, okay, if we join these lines, we will get one rectangle there. Okay, we get the rectangle there, and accordingly we can calculate the area of these small rectangles. Okay, area of this small rectangle, suppose this small we consider, if this is the one small part of the dx. Okay, this is the small part of the dx, and accordingly we have to multiply this small dx by respective value of the y. Okay, what will be the value of y from this place to this height? Okay, this will be the value of y. Okay, this much will be the value of y. We can consider here as the dy. Okay, to find out the area of this particular rectangle, we have to multiply these two terms. That is the, here we consider a small part of the x here, that is the dx, and this is the respective value of the y. Okay, and from this value we can get the area is equal to, area of the small part is equal to dy into dx. Okay, area of the small part is equal to dy into dx. Again, what is necessary, that to find out the exact area of this particular profile, here we consider this area, this part as the one rectangle. Then even if we consider this part as the one rectangle, you can see that here some portion of the curve is remaining on its top, here some portion of the curve is remaining, here also, here also. Okay, so again what we have to do is we have to divide this area again in number of small parts. Suppose we divide this into this small parts again. Okay, we have to divide this into some small parts again. Then what is there, that we are getting the number of rectangles again. Okay, if we divide this into number of small parts, then we will get some exact area of that particular portion. Now I have divided this, so again we can form the rectangles here. Okay, again we can form the rectangles here, and accordingly if we find out the value of this area of this small rectangular shape, then it will be more exact. Okay, it will be more exact. So if we divide this a rectangle into number of small parts again, then what is there, this dx is again smaller. So if you look at this, this is the first dx we are considering. Again it will get divided into this small portion. Okay, again it will get divided into small portion. So here what is happening there, that this dy is again coming to this place. Okay, again the dy is changing here. Okay, dy is changing here. So we are getting the irregular shape of this profile as the value of the y changes continuously with respect to this x. Okay, we are getting these two values. So what is condition, that in how many parts we are dividing that particular area in, and for that purpose we have to divide this horizontal x axis into number of small parts. Okay, so if we consider here, previously the length of this dx is greater, but again we divide this area into small parts, so length again decreases. So for getting the exact value of this area, or for getting the exact value of this area, what we have to do is we have to calculate such a number of areas here. Here we consider it is 1 dx, again here another dx is here, again here another dx is there. Okay, so like this number of dx we have to calculate, and their respective value of y will be there. And to find out the area, we have to take the multiplication as area is equal to dy by dx, and finally to calculate the total area of this area under the curve, we have to take the addition of all these processes. Okay, we have to take the addition of all this area, then we will get the value of the total area under this curve. Okay, and the method of dividing the area into number of small parts, then take its multiplications with the, take out its calculation by dividing its small parts, and take the multiplication of the respective value of y and x, and finally adding such small areas is nothing but the, we are doing the integration. Okay, so the two processes we are combining here in the integration. So first one is the multiplication, for which we can get the area of that particular quantities. Here we are getting the area by taking the multiplication with the horizontal and the vertical axis. Okay, the value of the vertical and the horizontal axis. From this we will get the area, and then when we get the area, we have to add such a small area, so that we will get the integration. Okay, and that integration will nothing but the area of that particular profile. Okay, so in case of integration, in integration it is nothing but the combined multiplication and addition. Okay, combined multiplication and addition. Okay, so like this we can go for the integration by combining the multiplication and the addition. We have to divide this small area into a number of small parts, and finally we have to take the area of that particular parts, and finally we have to sum all such a small areas. So we have to see now how integration is done actually, which are the formulas, which are the rules to be followed while applying the integration to any quantity. Okay, so we have to reverse the process of differentiation to find out the integration. Okay, so for that purpose also there are some rules. Okay, for the integration like the differentiation there are some rules. Suppose we have to go for the value of the integration. Suppose we have the equation that y is equal to x raised to n. Okay, we have the integration that y is equal to x raised to n. Then in that case its derivative is dx of y is equal to dx of x raised to n is equal to n x raised to n minus 1. Okay, this is the derivative of this function. Now if we have to go for the integration, then we have to take the reverse process. Okay, we have to take the reverse process. So in case of integration we have to go by here. Suppose y is equal to n x raised to n minus 1, then for after applying the integration we have to take the integration n x raised to n minus 1 dx. Okay, because dx is the term with respect to which we have to take the integration of this quantity. Then its integration will be n into bracket x raised to n minus 1 plus 1 upon n minus 1 plus 1. Okay, and it will become n into x. Okay, its derivative of y dx is equal to n into x raised to x. So that will be the formula. Okay, that will be the one formula. Okay, so if you notice that what is y is equal to x raised to n. Okay, what is y is equal to x raised to n. But here again we will get, here it will be x to n. Okay, we will get x raised to n. So if you look at this term, then you can come to know that we get the equation x raised to n after taking the integration of this function. Okay, this is the function with respect to which we are taking the integration, the n x raised to n minus 1. Its integration, we are applying the rules of the integration here, and accordingly we are getting that this n is a constant, then x raised to n minus 1 plus 1. So what is the rule of integration here is, if we have to take the integration of x raised to n dx, then it will be x raised to n plus 1 upon n plus 1. Okay, we have to take the x raised to n plus 1 upon n plus 1. So like this there are some rules for the integration. Suppose we have to go for the integration of any term cos x. Okay, y is equal to cos x is the term given, cos x dx it is given. Then what is the integration of this term? So its integration is, what is the value of the sin x and what is the value of the cos x. There we know the integration of a cos x is the sin x. Okay, because the cos x is the derivative of a sin x. Okay, what is the derivative of sin x? d dx of cos x dx is equal to sin x. Okay, so these are the some formulas. We will see the list of the formulas which we have to be used for solving the integration. Okay, there are some formulas which are nothing but the reverse of the derivation, okay, reverse of the derivative of that particular quantity. Means we have seen the derivative of the sin x is the cos x. Then what will be the derivative of a cos, integration of a cos x? It is nothing but the sin x. Okay, so we'll say one by one formula. 1 x raised to n dx. Okay. The integration of x raised to n dx is nothing but equal to x raised to n plus 1 upon n plus 1. Okay, x raised to n plus 1 upon n plus 1. Then the second formula, if we see, the integration of sin x dx is the minus cos x. Why I am writing here the cos x? Because we know the derivative of a cos x is minus sin x. So if we take the integration of a sin x, it will be the minus cos x. Then the third one, if we see here, integration of a cos x dx, it will be equal to sin x. Okay, the integration of cos x dx is nothing but equal to sin x. Okay, then similarly, if we calculate the another values, suppose we have to calculate the integration of the any other term, like suppose here is the one term, and accordingly if we calculate the one value, suppose we have seen d dx of x raised to n, it is equal to n x raised to n minus 1. Okay, n x raised to n minus 1. Now if we take the integration of this term, then if we get any value, okay, then if we get any value as the answer of the integration, then that type of integration is known as the definite integration. Okay, that type of value is known as the definite integration. And if we are getting the any relation, okay, if we are getting any relation, then that type of integration is known as the non-indefinite integration. Okay, indefinite integration, because when we take the integration of this term, we get this value. Okay, but when if we take the d dx of x raised to n plus 250, what is its answer? It is nothing but n x raised to n minus 1. Okay, means where is this 250? We know it is a one constant and its integration will be 0. Okay, plus 0 we have to consider here. Again, if we consider d dx of x raised to 3 plus 50, okay, then what is its integration derivative? It is 3 x raised to 2 plus 0. Okay, so what we are getting, the derivative of such terms, that is x raised to 3 plus 50 is equal to 3x square plus 0. But now in integration, what we have to do, if we consider its integration, okay, if we consider its integration, then what is the integration of this term? What is the integration of this term? If we integrate this term, the integration of 3x square dx is equal to 3x raised to 2 plus 1 upon 2 plus 1. So it will be 3x raised to 3 upon 3. Okay, we will get x cube. Okay, x cube. Now what is the integration of this term, or this term is the result of which term? This term. Okay, x cube plus 50. But now if we consider the integration of this term, then we come to know that the integration of this term is only this term. Okay, we can get only this term. Then what about this constant term? Okay, what about this constant term? Then for that purpose we have to consider one indefinite constant here. Okay, we have to consider one indefinite constant here, and whenever we take the integration of such any equations or such any algebraic expression, then each and every time we have to go for the indefinite constant. Okay, so how to write the integration of this term? The 3x square dx is equal to 3x raised to 2 plus 1 upon 2 plus 1. We will get x cube, that is equal to x cube. Okay, so we have to add one indefinite constant into it. Suppose it is a plus c. Okay, so this c is nothing but one indefinite constant. Okay, this c is nothing but the indefinite constant. Okay, so whenever we are getting the any algebraic expression, and for that purpose we have to take the integration, then we have to add one indefinite constant into it. Okay, that is the case of the indefinite integration. Okay, whenever we are getting any value, any algebraic expression, and we have to consider its integration, then we have to take the plus c or plus k plus any value, we have any constant term we have to consider here, then that type of integration is known as the indefinite integration. Okay, because this value is can be any variable. Here this value, we know this c is 50 here, but we don't know that here it will be 50. It can be any value because c is the one constant, it is the one variable, we can assign any value to that c. Okay, so accordingly we have to consider here one indefinite constant so that we can put our value of 50 there as the result. Okay, so in case of a result of any indefinite integration, what we have to do, we have to consider any one indefinite constant there. Okay, we have to consider any indefinite constant, then and then only it will be easy for us that it is the value or it is the one relation. Okay, this type of value, this type of answer is not the one constant, this is not the one definite value, this is the indefinite value, and that's why we are calling this constant as the one indefinite constant. Okay, so whenever there is the algebraic expression, we have to write there plus c or plus k or plus a, any constant you have to consider there and add it into that answer. Okay, that will be your indefinite integration. Now what about the definite integration? Okay, what about definite integration is that some limits are given to your equation. Like suppose we have the equation, suppose we have one equation that y is equal to t raised to 3. Okay, we have the equation y is equal to t raised to 3, and for this some limits are given. Okay, the limits of that equations are given as the integration from 2 to 5. Okay, the limits of this equation are given as the integration from 2 to 5. Then in this case what we have to do, suppose this is the one equation of a curve, then in this, suppose this is the equation. Okay, this is y, this is t, then whatever the value of t there, accordingly if we get one curve, okay, in this curve here is the 0, then 1 2 3 4 5 6. Okay, 1 2 3 4 5 6. Okay, so in that case, as the limits are given from 2 to 5, okay, limits are given from 2 to 5, we have to find here the area of that particular equation. We have to find the value of that particular equation between the only limits from 2 to 5. The limits are given from 2 to 5. So we don't have to go for the area from 0 to 2. We don't have to consider this area from 0 to 2 or beyond this 5. Okay, we just have to find out the value of the equation between these two terms from 2 to 5. So in that case, what we have to do, we have to find out the value of 0 to 5 first. Okay, find the value from 0 to 5, then find value from 0 to 2 and subtract it from 0 to 5. Okay, subtract it from 0 to 5. So in this case, when we have to find out that equation particularly, what we have to do, we have to first go for this total value from 0 to 5. We will get the value of this curve from 0 to 5, and from this we have to subtract this. Okay, we have to subtract this value from 0 to 2. Then we can get the value of this equation from 2 to 5. Okay, then we will get this value from 2 to 5. Okay, then and then only it will be possible to find out the equation, and we can get the definite value there. It is the definite value, and that's why this type of integration, whenever the limits are given for that particular algebraic expression, then that type of integration is known as the definite integration. Okay, we have to go for such definite integration there. Okay, so we will get the definite value here. We don't have to go for any consideration of the algebraic expression. Suppose we have this equation y is equal to 2 to 5 t cube. Then how to take the integration of this? That integration y is equal to integration of this term will be 3 t raised to 3 plus 1, sorry, t raised to n plus 1 upon n plus 1. Okay, so it will be t raised to 4 upon 4, and we have to apply the limits to this equation as 2 to 5. Okay, we have to apply the limits to this equation from 2 to 5. Then in this case, how to apply the limits? Just we have to subtract the value of the lower limit from the higher limit. So in this case 1 by 4 is common here, then we have to put the 5 here. So 5 raised to 4 minus 2 raised to 4. Okay, 5 raised to 4 minus 2 raised to 4, so we'll get 1 upon 4. 5 raised to 4 will be 525 minus 8. Okay, so that we will get here the value 517 divided by 4. Okay, so we are getting one definite value there, one complete value there, and we don't have to go for any consideration of a constant term. Okay, here you can look that here is the numbers are here, and we know the numbers are the permanent constant. They are not changing their value with respect to any conditions, with respect to any situations. Okay, so we are getting the permanent values there, and that's why that type of integration is known as the definite integration. We are getting the definite value of that particular integration. Okay, we are getting the definite value of 517 by 4 here, and by putting the limits from 2 to 5, just we have to put the value of t as the 5, value of minus upper limit minus the lower limit we will get here. Then 1 upon 4, 525 minus 8, that is 517 by 4. Okay, so this is the value of the your definite integration. Okay, so like this you can find out the definite integration and indefinite integration depending upon which variable is given to you. Okay, so in the equation we know what is the value of velocity. How to give the velocity here? We know velocity is given as dx by dt. Okay, so velocity is given as velocity is equal to dx by dt. Okay, now how the dx is given? Dx is given by the v dt. Okay, dx is given by v dt. So in this case we have to integrate this velocity with respect to time. Okay, we have to integrate this velocity with respect to time. So we have to put some limits here, and we come to know that v is the one variable here. Okay, if we took this integration here, we come to know that v integration dt, it is nothing but the v into t, and putting here some limits, suppose from 0 to 2, 0 to 2, then we can put here 0 to 2, we will get v 2 minus 0, we will get twice v. Okay, dx is equal to twice v. So in this case we are getting one indefinite term, so we have to add here plus c, because v can be any variable. We can assign any value to this v because it is not one constant. Okay, so accordingly if we consider the equations like acceleration is equal to, what is the acceleration? Acceleration is nothing but the derivative of the velocity. Okay, acceleration is nothing but the derivative of the velocity. Then in that case we can consider the velocity is the one variable term. Okay, so when we take the integration of the velocity, we will get the displacement. Okay, when we take the integration of the velocity, we will get the displacement, and when we take the derivative of the velocity, we will get the acceleration. Okay, when we take the derivative of that term, we will get the acceleration. So like this way we can use our calculus method for the solving the problems of a very irregular shape in case of some irregular profiles, and we will get the exact value of that particular shape, the exact value of that particular area by applying the method of calculus. Okay, so the differentiation and the integration, these are the two processes in which in a differentiation we have to go for the combining the division and the difference together, and in case of integration we have to reverse this process by combining the multiplication and the addition. Okay, whatever the formulas of the differentiation, we just have to reverse that formulas to get the value of that particular integration. Okay, so remember the methods of the calculus, that is the differentiation and the integration. Now in the next lecture we will study about the some problems based on this formula of the integration, the method of the calculus, that is the integration.